Hello, I am HampsonRussell, Senior Geoscience Technical Advisor working for CGG Geosoftware based in Crawley. Today I would like to introduce the way that Emerge module of Hampson-Russell software can help in enhancing or interpreting the seismic inversion results or AV attributes. As you know, seismic inversion is done using Strata module in pre-stack or post-stack inversion mode, and AV attributes can be estimated using AVO module. So the idea is how to add value to the results obtained from these modules by applying Emerge module. So why use Emerge? Because sometimes we need to build a low frequency model for strata inversion incorporating seismic velocity and well logs. In this case, seismic velocity will be guiding interpolations of the logs within the model. Or we have inverted seismic data and need to estimate reservoir petrophysical properties like porosity, water saturation, weak lake, or gamma ray volume, or in theory, any other attribute that we would like to estimate from inversion results. Estimation can be done using simple regressions, but the estimation can also be enhanced using multiple attributes or enhance the resolution combining multiple attributes and neural networks. This can be done using Emerge. We want to estimate reservoir properties or classes using AVO attributes. For this case, class means the class of the lithology type or fluid type, or lithology fluid type classes. So this we're classifying the data based on their properties, not just AVO classes. And we want to estimate missing logs at few wells using the existing common logs in other wells. So this can be done using Emerge. Let's look at some examples now. This example is showing a low frequency model calculated using Emerge. The top one is a p-velocity model, which is using only the strata from the Hampson-Russell. In strata, as you know, it is interpolating well logs and within the structure. And if we use Emerge in the lower panel, which is using seismic velocity as a guiding and incorporating seismic velocity to the low frequency model. As you can observe, the main difference is that the top section, you can observe that the deeper section of the model, the wells are not penetrating deep enough, and strata volume calculation is just extending the deeper section of the well to the deeper section of the model. So this is not the case, because if we use the seismic velocity data, we will be able to limit that extension to the places where seismic velocity showing us that there is some layer there. Or when you go deeper, the seismic velocity guides that the value should be less than the blue value, which is used in the last point of the well. Another example is how the prediction can be done using different methods within Emerge. We are using multilinear regression or neural networks, and we are going to estimate porosity using a seismic inversion results, which is shown in the left panel. The left panel is acoustic impedance and in color, and VGLs are the seismic data, and overlaid by a p-wave velocity log. And to the right panel and in the middle, so we have used Emerge in the neural network using neural network method, and we are estimating porosity in using those attributes, which is the seismic inversion results. Or we can use multilinear regressions again to estimate the porosity volume. So this can be used to estimating the seismic property, reservoir properties from the inversion attributes as well. There are some differences between the two results, so it depends on the methods we are using and the parameters we are using for training the Emerge processes. Next example is using again inversion results to classify the reservoir based on the three classes of the porosity. So different values of the porosity is corresponding to each class. So the class 3 is highest porosity class. So this example classification is done using the neural networks, which is shown in the middle panel. Left panel is acoustic impedance out of inversion, and also we are able to estimate the probability of existing class in that location, which is shown in the right panel. So that simply is, for example, in the right panel shows that, for example, this high porosity class 3, how much is the probability we are having that class there. So we can estimate that using this Emerge neural network method. So for this case, we are having this class 3 and with a higher percentage of the probability at that location. So this is giving us that indication that so we can have that higher porosity there with that probability. Next example is using Emerge and AV attributes from Christopher Ross to image the gas sand reservoir. So they had these many wells drilled and they wanted to compare which method is giving the best imaging, best image for them. So they, their studies resulted in that if they use AV attributes A and B and the seismic amplitude to be used in Emerge, they are able to estimate a VPVS, and this estimated VPVS is clearly giving the extension of the reservoir channel without any doubt. So there is an interpretation is very unambiguous and presenting just the gas sand. So this was done using Emerge and using AV attributes in this case. Another example is estimating P-wave log at well C and well D using the available logs in well A and well B. So as shown here, there are measured logs are available in black, is shown here, so in the well A and well B, but they are not available in well C and D. So what is happening, we are going to use the common logs to all wells where resistivity, density, and gamma ray. So using Emerge in regression method, and we try to establish a relation between the resistivity, density, gamma ray, and the P-wave velocity, and we are going to apply that relations to the wells which they don't have these logs, and we are estimating this P-wave log for the wells which they are missing inside that well. There are some QC tools inside Emerge, so you are able to check the quality of the predictions at the known locations. For example, for this case, we have two wells that we have known, we have measured data sets. We do the predictions using these relations, which was estimated using Emerge, and we calculate the predictions, which are red shown in here, and we can establish this cross plot and apply a regression and see how much is the error or the correlation of the predictions to the measured data sets. This is one of the use of the Emerge to estimate log or missing intervals within the logs. But let's go to Emerge introduction. So Emerge is a powerful statistical tool within HampsonRussell. It is powerful, statistical, but yet intuitive and easy to use, and uses multilinear regression or nonlinear neural network approaches for predictions. Emerge predicts log property volumes from well logs and seismic attributes data. Seismic attributes means could be AVO or inversion results or other attributes like some extractions from the seismic data like lambda or mu. So this type of attributes. Emerge can increase the resolution of the inversion results, and especially in the neural network, once we're using neural networks. Image can classify the reservoir using the seismic attributes and estimate probability of each class. The class means, as I mentioned, it is lithology of fluid classes, which we define based on the logs, for example. Image to predict missing logs or intervals of the logs which are missing in the well by using existing logs that are common to the available wells. And if we go to the workflows for the how we can use Emerge, this is a workflow for estimating low frequency modeling using seismic velocity and velocity logs. Optionally, we can input other attributes as well. So for this example, we have RMS velocity seismic data. we input p-wave logs, and because we are going to estimate the p-wave or p-velocity low-frequency model. So we tie the wells to the seismic data, and we can convert RMS velocity to interval velocity. Then we can input optional attributes like inversion results, like acoustic impedance. We start training the Emerge, establishing relationships between the p-wave and the attributes. Then applying Emerge, we are going to get a volume of the Emerge velocity volume, which is not necessarily tying exactly to the well, so there will be some residuals between the volume and the well logs, so we can calculate the residual well logs and do the interpolation within the strata model. Then we will have a residual velocity model. We can add these together, velocity from Emerge and residual velocity from strata, and we can combine them and get the final low frequency model. This low frequency model will be following p velocity, which is coming from the seismic processing. This example is to build for p wave, but for density and s wave, we can also use almost a similar workflow to estimate those low frequency models for those parameters. The next workflow is to estimate reservoir properties or lithofluid classes in the reservoir using the inversion or AV attributes. So in the input data, we can have an inversion result. For this case, for example, P wave, S wave, lambda rho, mu rho, or density or velocity, and logs, target logs, which target logs mean we are going to estimate, for example, porosity, so we need to have that target log as a training data at the wells. Then we define the attributes and targets. As I mentioned, target could be any target, so it could be water saturation, porosity, VKLA, gamma ray, etc. Once we define that, then we go to the training step, and we start training and establishing the relationships. Once we identify that, we have two options. We go regression method or we go neural network method. In the regression method, we are able to estimate the property that is our objective. And for example, we can estimate porosity. But in the neural network method, we are able to estimate classes and the probability for each class, and also the probability of having that class, the most probable class, as well as I showed in the example. Or again, we can use this for predictions, again, porosity volume, for example, for the reservoir. But if you want to estimate missing log or some intervals of the log which are missing inside the wells, we can follow this workflow. We have some wells, we need to have wells with available log, and they should have the common logs within all the wells. For example, all of them should have gamma ray, resistivity, and different type of logs, which we can use them to train the relationships between the missing log and these common logs. And also we should have that measured the log in the other wells as well. So we are having to sample data to train the relationships, then apply that relationship to the missing to the well which has missing data set. So this workflow is the same as before almost. So we establish training, and we use regression method for this case to generate those missing logs. For this case, it was p wave velocity, which was measured, which was predicted for these two wells, which they didn't have these logs. But image workflow, how it is done. So the attributes are used to estimate target log. So we need to have target log at well location, and Emerge establishes a weighted method, arithmetic weighting, and applies these weights to each attribute, and add them together and calculates a regression based on different attributes. So this relation is found between the log and the seismic data attributes at the well locations. This relationship will be used where you don't have this target lock at those locations, and it will be applied to the attributes which are available at that location, for example, coming from the inversion, coming from the AV analysis attributes, or coming from the seismic amplitude attributes. So those are those relationships will be applied to predict the target at those locations. We don't have a well everywhere, so we are calculating property for each CDP. So that is the idea. We are going to use Emerge to calculate target attribute. But what are the attributes in Emerge? The attributes are called internal or external to Emerge. Internal attributes are based on seismic data. They can be stacks of the seismic data. Emerge can calculate 17 other attributes from seismic data, like different derivatives, filter panels, instantaneous image, instantaneous frequency, or phase, or those attributes. There are also some attributes called external to Emerge. They are internal to HampsonRussell, but they are external to Emerge. You can also import from the other sources as well, so like P-impedance, S-impedance, density, VPBS ratio, and AV attribute analysis like incident and gradient, intercept and gradient, and combination of those attributes can be used, and they are dealt as external attributes to Emerge. Apart from that, these attributes can also be transformed to other forms, like we can convert them to logarithmic form or 1 over x square roots, and you can use those to establish better relationship between the target and the attribute which is used in the Emerge. All right, we talked about attributes and what are those to Emerge, but how the attributes are evaluated and selected, the individual attributes, then how do we combine them, how do we select how many number of the attributes to be used for in a combination. So what is done in Emerge, each attribute, for example, for this case, 1 over inversion is going to be used to predict porosity, and each attribute is used to predict that porosity. For example, the 1 over inversion is used to predict porosity at the known locations. So there will be error between the predictions and the well measurements. So the RMS of the error will be calculated for that specific attribute, and all other attributes will be ranked based on the prediction errors. So we will know that which attribute is giving us the best possible predictions. The next step will be combining these attributes. So how it is done? It's done in a stepwise procedure. I will explain a little bit later. We combine the attributes, and again we rank their combinations, how the combination is giving us the best predictions. And to select how many attributes to combine, it's done using the validation. So let's go for the selection, the combination. Suppose we have 3 attributes to be used, and each single attribute will be ranked, and the most appropriate one, which is having the least error, will be used for the first attribute. For example, say we have this amplitude weighted phase coming from seismic data. Average frequency, again coming from seismic data, apparent polarity, etc. Can be an inversion results, can be AV attribute. So the attribute 1 is selected because it's giving us the least error, so the weight will be applied to that to predict the target lock. So this will be our first attribute. The next attribute will be selected using the remaining attribute from the list. So the second attribute will be combined with the attribute 1, and the third attribute will be combined with the attribute 1. Again, the prediction error will be calculated. The one which is giving the lowest prediction error will be used to in the combination. Next step, so we have 2 attributes are available now. We have defined them. The third attribute will be evaluated, and again will be prediction error will be calculated and listed. This can be carried on for as many attributes as we have, and so there is no limit. But we need to define how many attributes to combine. Define how many attributes we are going to combine. Emerge uses validation error, so validation procedure. In validation procedure is like a blind test. You blind one well and you calculate the coefficients using the other wells, and you estimate that relationships, then apply to the well, and you estimate a prediction. For example, the red one is predictions on these logs, and the black one is the measured values in the wells. So there will be prediction error for that specific well which was blind. Then this will be calculated for each well in step. So for the combination in selected combination of the attributes, and finally we will get we'll do this for all the wells, and the average of the errors will be calculated for all blind tests like this, and it will be registered for that specific combination. This will be done for different attributes. For example, we are using 7 attributes from this multi-attribute list for this case. This is done for each combination, and we can get these each values of the prediction errors, and we can draw a validation plot for the number of attributes. So these are the validation values. So we are using for this case 1 single attribute, a combination of the 2 attributes, 3 attributes, etc., up to 7 attributes. In general, the prediction error decreases by increasing the number of attributes, but in some point, by increasing the number of the attributes, you see that the prediction error also trying to increase. So the point which is giving us the best combination is, for this case, is 6 attributes. So for example, at the right panel, you can see the list, which is starting from inversion, filter of the seismic, time, quadrature trace from seismic, filter panel, and integrated absolute amplitude. So if we combine these attributes together, we will get the prediction validation error of the lowest possible validation error. So this is good. This will be a good combination of the attributes to be used for prediction of our target, which is porosity. But the multi-attribute analysis correlates each target sample with the corresponding sample on each seismic attribute. But there is a big difference between the frequency content between logs and seismic data. So to account for that, Emerge is using a convolutional operator to extend the cross-plot regression to include neighboring samples. So instead of having just one sample from the attributes which has a lower frequency content to be compared to the target log, we are including many samples around that neighboring that point to be able to account for this difference in the frequency content. Each target sample is predicted using a weighted average of a group of samples on each attribute rather than individual sample itself. And this weighted averaging is convolution. And to select how many samples points we need to select, again, the validation technique is used. That is all for regression. Regression, as you know, it is a linear regression is applied, although there is some transform that we are applying to the parameters. For example, we use a square root or 1 over x. We transform it to different forms. It becomes non-linear almost, or we use a convolutional operator. It becomes, again, non-linear form. But in general, it is linear. But sometimes there is a non-linear relationship. So we are going to extract that and apply that to the predictions. Emerge uses neural networks methods to account directly for non-linear relationships between logs and attributes. Within Emerge, we have 4 ways of using neural networks. One is a multilinear feed-forward network. The other one is probabilistic neural network, which can be used for classification of the data or doing predictions of the properties. Radial basis function neural networks and the discriminant analysis neural networks are the 2 other ways that the neural networks are used in Emerge. This in the right, you will see the simplified diagram of a neural network. It has got input nodes, so the input nodes are the same number as the attributes we are using. There will be some hidden layer. These nodes are called in the second row are called in the hidden layer, so they are not visible to the input and output. There are some connection to the nodes, so these connections has weight on them, and each node has its own function. And finally, we will have an output node which is giving us the output value. So defining this neural network character, which means defining the weights, connecting the connections to each node from different nodes to each other, to the other nodes, and the function within each node need to be defined. So these are the parameters that need to be defined. So it comes to the training of the neural network. So based on the types of the neural networks, training means number of input attributes, how many attributes we are using. Usually we tend to use the attributes we calculated in the regression method, so because that's a good point to start. So we have ranked them based on their error, prediction error, so that's a very good point to start to start the network, neural network analysis. How many hidden layers we need to choose, finding optimum weights to be applied to nodes, connections, number of iterations to train the network, and sigma values within each node. So usually there are some functions like sigma within each node, so how to define that, this is also part of the training. To train the network, we need to have sample values in some locations to train the network. And Emerge uses advanced mathematical and cross-validation to train the neural network. This is an example of the applying neural network in the middle section. The idea was to use inversion results and to estimate porosity using Emerge, using two methods, regression and probabilistic neural network method. As you can see in the right section, the schematic diagram of the geology and the location of this channel has been shown in the geological time scale. And neural network is showing here better imaging as compared to the regression methods. As you can see that the upper layer is separated from the lower layer with higher porosity values. So this suggests that using a neural network within Emerge, it enhances the resolution of the inversion results. If we just use the regressions, we will get the same resolution as the seismic inversion. As a summary of the Emerge is a program that predicts properties from seismic attributes. Properties can be any properties. The seismic attributes may be internal attributes that are generated by Emerge, or attributes which are calculated by other programs, especially strata inversion and AV attributes. The relationship is determined using training data at well locations, which is then applied to a seismic volume. The attribute and the relationship is determined using statistical analysis. So there is no need for a particular model, and specifically if you are dealing with rock physics, so you don't need to worry about the rock physics model. This is just the statistical method of calculating attributes. The optimal list of the attributes is obtained using stepwise regression. The optimal number of the attributes to be used is observed by doing validation. To account for the frequency difference between logs and seismic data, convolutional operator is employed to extend the cross-plot regression to include neighboring samples. And missing logs in the wells can be predicted by building a relationship between this type of log and other common logs in the wells containing the log. Compared to stepwise regression, neural networks can enhance the high-frequency resolution and perform classification. This presentation was a general overview of the Emerge, which can be used to enhance your interpretation of the inversion results or AVO attribute analysis results. Thank you very much for your attention and time.